Thank you. Is that coming through? Can you hear me? Good. I thought I'd start with this. If there's anyone who doesn't believe all of those things are true, please leave, because, you know, you're not part of an intelligent society. Here's a little thing that we are doing in Reading. So, we have built a Archimedes screw turbine generation plant on the Thames. It's been built by Reading Hydro's CBS. CBS stands for Community Benefit Society. Entirely funded by investors, individual investors, entirely run by volunteers, and largely, well, except for the big stuff, it was actually built by volunteers. I go through a little bit of the history of, you know, how we got to where we are. So there's a organisation called Transition Town. There's probably transition towns in most large towns in England and Wales. Transition Town Reading was an existing group, and it was sort of looking at general energy things. And a group came together in 2014 and was sort of saying, yeah, we've got all this, we've got the Thames here, we've got all this water flowing over the weir, we should be generating some electricity from it. There's a huge amount of permissions, paperwork, planning, way leaves, etc. that have to be gone through. Council, Environment Agency, government, electricity. You wouldn't believe the amount of paperwork involved in doing something like this. So we had some initial funding. This was just, you know, the group that was sort of forming around it. Everyone put in 100 quid, and we had some money to start doing some initial surveys. It was considered that we could do it. You know, the key thing was the financial model. Could we actually generate enough electricity to cover the costs of building the plant? And we started the process of all the applications. Environment Agency, but Council, Ofgem, and the crucial thing was trying to get a feed-in tariff agreement. So that's how much we're going to be paid for the electricity we generate. Then we moved into the major funding. So that was a share offer scheme where we were offering shares for investment in the plant. We raised, in several phases, we raised £1.2 million. Once we had that, then we started the prep work. A lot of the prep work was all done by volunteers. We would, at this stage, negotiating with various suppliers to build the major parts of the hydro scheme. The first thing we did, sort of major thing we did, was the pontoon bridge. So that was so we could bring the heavy equipment across. I'll show you an aerial view. So there's a small stream called the Mill Stream. We had to cross over to get to the end of the weir in Reading. October to January 21, if you remember, that year was quite severe flooding. We the way you do this, you build what's called a coffer dam. I've got a picture of this. This is a coffer dam. So it's a set of metal plates, corrugated, that are driven into the riverbed, and then once you've sealed that all up, you can then pump the water out of the middle, and then you've got somewhere to start working. The coffer dam itself was flooded twice, and we had to stop work. At this stage, this is all of the civils work. So the digging out, the laying of the concrete for the actual sluices where the water would flow. At the same time, part of the agreement to build this is that we would have to deal with creating a fish pass. So there is a fish pass on Caversham Weir, but it's only really good for strong fish, sort of salmon and trout and things like that, to swim up. Eels and things like that can't swim up. It's too steep. So we were creating a fish pass through View Island, which is sort of off to the left of these pictures, and that was all done by volunteers. Construction, the major civils completed February 21. If you remember, this was sort of in the middle of COVID. We were doing community construction at this time, so we were just as we're starting to build the turbine house. Again, the turbine house was all built by volunteers. We then had a major job, which was to install the connection. So if I move my mouse, you might be able to see. In the top left corner of that picture is where the actual turbines are. We then dug a trench across to this point here where the end of the blue line is. We had what they call a ditch witch, which is a guided drill, so they drill underneath the Thames. We had to go across here because we weren't allowed to drill underneath the lock. So we had to move it up to this point so we were clear of the lock. We then dug another trench from the other end of this back down to the Reading Lido, which is a restaurant and swimming pool, where there was a grid termination where we could connect into. The cable, it's a 4-conductor cable, so it's 3-phase electricity. It's sort of about this diameter. There was a lot of discussion about, exactly what size of cable, because the cross-sectional area of the metal contacts determines the resistance of the cable, and so more resistance, more energy loss on the cable. So all of this calculation goes in place to work out, what's the best solution for that. Here's the actual drilling under the Thames. We then had a one-day event where we had 60 volunteers from Reading, and we pulled the cable through the ditch the thing. So you can see here on the left-hand side is the actual ditch which drilling the hole. Once the hole was drilled through, we attached a pipe to that and pulled the drill back, and that pulls the pipe through it. We then feed a draw cable through the pipe, and then use that with a winch to pull the cable through the pipe. We then had the actual turbines installed these are the turbines that were made by Spans. They were shipped over from Germany and arrived on low loaders. We then had a crane to lift them into position. The rest of the equipment installed, so you can see there the green are the actual generators. There's two generators. Behind that is a gearbox. The turbines themselves turn at around 30 RPM, but the generator needs to turn at about 1500 RPM in order to be optimal in generation. We then had a lot of checks and compliance forms and things like this to fill out, check out all of the equipment was installed to specification. August 2021, we finally got all the certificates and we had the opening ceremony. But there was a drought at that time. The flow in the Thames was very low. So we were there, we were all ready to go, we couldn't switch on. September 2021, finally we'd had a bit of rain, the levels were a little bit higher, we were at a point where we could just turn on. Just at the end of September 2021, we started generation. The main bit I've been involved in is the data system, the website, and how we collect all the data. So all of our data is completely open. Anyone can go and access it. There's an open API for, and I'll show you the pages on how you can connect and examine our data. The generation system is controlled by a Siemens control system that runs Windows PE. Yes, it's still out there and being used. Essentially, it's a version of Windows 98, which is the sort of GUI interface system. We've plugged a Raspberry Pi into that, and with some libraries we're able to pull the data off the control system to tell us what's going on. We then send that over a MQTT to a cloud server running in Linode. That puts it in a database, and then the website accesses the database and it displays it on the website. We also have in Reading a LoRaWAN network. It's run by the council. It sort of covers the whole of Reading, and we put a base station for the LoRaWAN network in the turbine house. That gives us good coverage around that area, and it's actually part of the council network, not really part of Reading Hydro, but we use it. And we use it for a number of sensors, the environmental sensors, so the fire detection, temperature, humidity. We have sensors on the doors. We don't have any cameras. Sort of still a bit of a debate there, but we just don't have any cameras. We also have one of the things I did was the alert system. So we looked at things like PagerDuty and things like that, all very expensive. And so I said, I can do better than that. I can write some Python and do something. So basically it just simply reads a Google Calendar. In the calendar is who's on shift for that day. At 7 o'clock in the morning, it sends an email to that person, say, hey, you're on shift, please acknowledge, and a little button there to acknowledge the reminder. If there are any alerts on the system, then it sends a message to whoever is on call. We have an on-call in a second, and then waits for an acknowledgement to make sure it's been read. If it hasn't been read, it sends it to another email address, which is an exploder. This is the operational and maintenance team. We have a sort of a number of maintenance tasks that we have to do regularly on the system, like, you know, greasing some of the bearings, cleaning things, checking that the emergency shutdown and all those sorts of systems are working. There's a separate team. So the thing I didn't mention back when I was talking about the data was the connection to the turbine house. There's no network facilities there, so we've got a Teltonics modem running OpenWRT, and that's got a GSM modem in it, and that links into that gives us our network connection. We then have the remote access is achieved through a WireGuard, and then you can then connect VNC onto the actual control system, and you get the actual control system as it's displayed in the turbine house. We also have a team that clear, so the front part of where the water comes in accumulates leaves and shopping trolleys, Belika beatons. Everything you could possibly imagine gets washed into there. We have a clearance team that come regularly around and rake the leaves out and keep the inlets clear. We also commissioned a local artist, Commander Jundasil, who designed. We actually had a competition for the mural on the outside, and then he designed it, and then sort of volunteers came and, you know, filled in all the bit, did all the painting, did all the little twiddly bits and things like that. There's a whole lot of little animals along the bottom, you know, moles and rats and things like that, beavers, etc. along the bottom. A lot of those are filled in, and it's, you know, quite a talking point in Reading. We have had a bit of graffiti. We've put some graffiti paint on it, which is a sort of transparent paint that lets you take off the graffiti, but we have had some where we've had to repaint some bits because they've used car spray-on paint, which is really tough to get off, but not too bad. We also have climate stripes on the side of the turbine house. This is an initiative by Ed Hawkins in Reading University. You may have seen climate stripes around the place. They give you a sort of visual indication of the warming of the planet. And we've got a little space on the right where we're going to add new stripes as the data comes in. I do want to just show you, if I've got time, I think I've got a couple of minutes, is show you some of the live data.
10 minutes.
If I can find where's my mouse? No. So, yeah. Can't see if that one was. There we go. Okay, so this is this is the generation at the moment. Let's see, is that right? Yeah. So you can see the two turbines there and the amount of power that's being generated. For each turbine, sorry, this is hard to do when I can't see what I'm doing. And this is the other main screen, which is showing the river levels. Now, the important thing about electricity generation, especially these things, it's not the flow of water, it's the drop of water. So you've got the water level incoming to the weir, incoming to the turbines, and then the level going out, the downstream. So the upstream and the downstream. And then the difference between that is the head. That's what we're actually using. Each turbine is using about 3 cubic meters of water a second. So that's 6 cubic meters a second for the two turbines. It takes about 3 seconds for the water to flow through the turbine. So that's roughly a cubic meter of water is roughly a metric ton, or is exactly a metric ton. So that's roughly 8 to 9 tons of water that is in each turbine at any one time. And it's that weight of water that turns the turbine that generates the electricity. You can also see we have on the bottom here, this is data from the Environment Agency showing the flow of water down the Thames measured from Reading Bridge, which is just upstream of the weir. This is a page which we've created which just shows the environmental data, and we've added sensors to the sluice gates. So the sluice gates control the flow of water into each turbine, and this is giving us a level management. This is something that the control system didn't have. How am I doing for time? Okay. This is the alert, so this is just logging all the alerts that come through on the system. And then the acknowledgement page. I mentioned the data, the data, that's all the software that we've generated is available on GitHub, and the API is completely open. There's the documentation on the wiki on GitHub on how to use the API. If you can think of some imaginative use for the data, you're welcome to do that. Now, if I can get back to the presentation, there we go. Thank you very much. I will be in the question tent afterwards. You can come and ask me about all things electricity generation and things like that. There's lots of things I haven't covered, so I hope that's interesting for you.